Okay, this video is it all the same disease? This is part 5. Okay, we're going to talk a little bit about fat here, and we're going to talk a little bit about diabetes. So again, what I'm basically showing here with this series of lectures, is it all the same disease, is that the standard American diet, the westernized diet, the high-fat diet, it just causes all these problems. It causes obesity, it causes hypertension, it causes diabetes. These diseases cause atherosclerosis. The same diet is low in fiber, high in fat, so it causes leaky gut, and that leads to autoimmune disease. That leads to postprandial endotoxemia with subsequent more thrombotic blood. The high fat as well is another cause of thickened blood, increased blood viscosity, which worsens atherosclerosis, causes tissue hypoxia, increases cancer. Okay, so all of this stuff is like the gateway to destroying yourself through chronic degenerative disease. All right, so here's just a little bit about dietary fat. Sat fat has no double bonds. A MUFA is a monounsaturated fat. It has a single double bond. The characteristic thing of a MUFA is olive oil, like an omega-9 fat. Here are PUFAs, polyunsaturated fatty acids. Poly meaning more than one, unsaturated meaning a double bond. It's graded by or described by where the double bond is. So this is the methyl end of the carbon. Here's a carboxylic end where the carboxylic acid is. And you just count from the methyl end the number of carbons. 1, 2, 3, 4, 5, 6. So the double bond's at number 6 position. So this would be an omega-6 fat. With an omega-6 fat, it's a PUFA, so there's 2 or more double bonds. There's a skip carbon in between the next double bond. That has only a weak grip on its hydrogen at the skip carbon. There's going to be actually a hydrogen above and below this carbon right in here. And so it's called a methylene group, therefore it's called a methylene bridge between the double bonds. It has only a weak grip on its electrons. It's very easy for this hydrogen to be plucked off and for oxygen then to bind to the spot. That's the beginning of lipid peroxidation, when these fats go rancid. That's why if you buy, like say, an omega-3 supplement, it'll be in a radio-opaque bottle, and you're supposed to keep it in the fridge to prevent lipid peroxidation, because otherwise they often undergo lipid peroxidation, and they routinely do. And quite often the supplements are sold, they're already contaminated with lipid peroxidation. As you probably heard before on my other lectures, I do not recommend any oils whatsoever. None. Zero. Not one drop. I agree with Caldwell Esselstyn. Not one drop. Okay? And with Dr. McDougall. Not one drop of this stuff. Okay, so an omega-3 fat would be starting at the omega-3 bond. Okay? All right, here's the example lipid peroxidation. The hydrogen's plucked off. Now you have a free radical, meaning an electron that's unpaired in an outer orbital. Oxygen will bind to that. 2 oxygens in a row bound to the molecule is called a lipid because it's a fat lipid. Peroxide. 2 oxygens in a row is a peroxide. And this is very strong tendency to cause chain reactions where it'll destroy membranes and destroy other tissues. Your antioxidants are to neutralize those things. Okay, now a little bit here about diabetes, because that was really the main gist of this chapter. Is diabetes is a disease of fat. Everybody thinks of diabetes as a sugar disease. That is the wrong way to think of it. Yes, you do get elevated blood glucose, but that's a symptom of diabetes. The real cause of diabetes is excess dietary fat. It overwhelms the skeletal muscles. I'll explain how in just a moment. But first of all, you get fat accumulating in the skeletal muscles after eating. Eating is called prandial. So postprandial means after eating. Hyperglycemia is due to fat accumulation in the skeletal muscles, and that inhibits mitochondrial function. I'll explain that in a moment, but that's the key thing you know. You need to know that the main cause of diabetes is excessive dietary fat, especially sat fat, but all fats increase the risk of diabetes. After the skeletal muscles start accumulating fat, you then start to accumulate fat in the liver, and you get a fatty liver. Fatty liver is like diabetes of the liver. And then eventually you start accumulating fat in the pancreas, and that's simultaneous with the pancreas beta cells dying, undergoing apoptosis. And it's very common, you look at a CAT scan of the abdomen, you see fatty replacement of the pancreas, and that's a characteristic finding in type 2 diabetics. And then once you've got your full-blown diabetes, you get more and more other end organ complications. The high blood glucose damages the eye, retinopathy, damages the kidney, nephropathy, damages the blood vessels, vasculopathy. Okay, so the key thing to know is that the skeletal muscle regulates its uptake of glucose by using insulin. It has glucose type 4 transporters that are insulin sensitive, versus there are some cells in the body, like your arterial lining cells, your endothelium, like your eyes and your retina, your kidneys, where they do not have glucose-dependent uptake Uptake is not dependent on insulin-dependent uptake. The glucose simply just comes into the cell in a constitutive fashion, meaning whatever the concentration in the blood is, you get a similar related concentration coming into the cell. And those cells are very vulnerable to being damaged by high blood glucose levels, hyperglycemia. When I talk about diabetes here, I'm talking about type 2 diabetes. Type 1 diabetes is a little bit different. That's when the pancreas gets destroyed, typically very young in life, most commonly due to autoimmune response to drinking milk. Okay, so anyways, here's what normal insulin does. Normally, insulin binds the cell receptor, and then once it's bound to the cell, that causes a series of reactions that lead to these glucose type 4 transporters, normally stored in vesicles in the cytoplasm, to diffuse up to the plasma membrane, merge with it, and release the glucose transporters into the membrane. And those then are channels to allow glucose to come into the cell. As soon as it comes into the cell, it's phosphorylated, it stays in there. Okay, that's how insulin normally is supposed to work. Okay, when you have a problem, like let's say you have excessive fat has gotten into the mitochondria, it will inhibit mitochondrial electron transport, and then you get a backup of the whole assembly line for processing energy from fats. And that'll send what's called an overnutrition signal to the insulin receptor in the plasma membrane, and it'll block these glucose type 4 transporters from going up to the plasma membrane. Because they're blocked from going up to the plasma membrane, now the glucose can't get into the cell, and the glucose accumulates in the blood. So you get hyperglycemia, high blood glucose levels. And those are the diagnostic tests for diabetes. Does the person have a high fasting blood glucose level? Do they have a high hemoglobin A1C? Do they fail the oral glucose tolerance test? Okay, so anyways, hyperglycemia then is going to cause a whole bunch of other complications. Another thing is people say, oh, fat's not a big deal. Yeah, right. You feed fat to lab animals to cause diabetes. Okay, this is pretty well known. An interesting experiment here was done by a guy named Anthony J. This is not the PhD Anthony J, lipid biochemist. This is another Anthony J and James Hamilton. In 2020, their paper is inhibitors of fatty acid transport across membranes do not affect fatty acid translocation. So what's this all about? The point was that the fatty acids can go right from the blood into the cytoplasm. They don't even need a plasma membrane protein to do it. And they use something called a fatty acid flip-flop maneuver. They would intercalate themselves into the outer leaflet of the cell's plasma membrane, the skeletal muscle plasma membrane, and then they would flip-flop to the inner leaflet of the plasma membrane and then go right into the cytoplasm. And you couldn't stop them by inhibiting the fatty acid transporters in the plasma membrane. It was simply occurring at a rate based on the concentration of the fatty acids in the blood. So that's why the more fat you eat, the more fat gets into your skeletal muscle, the more insulin resistance you get, the worse the diabetes. Okay? So the only way to handle that is to eat less fat. And that's why all that paleo, keto, carnivore stuff, low carb, it's all a joke. It's all a joke to trick the low IQ pros. It's nonsense, okay? And so again, this is the concept of fat being the key causative agent in type 2 diabetes. There's a little bit more that causes it. Elevated uric acid causes it. Excessive dietary sodium increases the risk of it. Mitochondrial inhibitors increase the risk of it. Some medicines that inhibit mitochondria increase the risk of it. Omega-6 cooking oils, which lead to lipid peroxidation, toxic aldehyde hydroxynonenal, and that destroys mitochondria. That also makes it worse. Okay, but I'm just letting you know. And here I'm going to show you this guy. This guy's a genius, Gerald Shulman. So here's Gerald Shulman. He's got an MD, PhD, Harvard-trained endocrinologist, and he also did a lot of work with MRI. And he's the one that did the definitive work. He won the Banting Award as the best diabetes researcher in the world in 2018. And this was his lecture, Mechanisms of Insulin Resistance and Their Implications for Type 2 Diabetes. You can find this lecture online. Just type in Gerald Shulman Banting Lecture 2018, and you'll find it on the internet at a couple of YouTube channels. Okay? And he also pioneered what is known as the ectopic fat theory of diabetes. Okay, so this is Gerald Shulman's illustration of how, what happens is you accumulate fat, pathogenesis of hyperglycemia and type 2 diabetes, and it's going to be because you have increased fat stored in these skeletal muscles. He showed that with magnetic resonance spectroscopy. Okay, you're also then going to accumulate fat in the liver, fatty liver, and that's going to cause prediabetes and diabetes. Eventually you get a fatty pancreas. Okay. All right, the accumulation of fat in the liver is just, typical diabetes. And I can tell you, I see fatty liver all day long, every day. If I hear that a patient has elevated liver function tests, I don't even look at the chart. I automatically assume they have a fatty liver. If I hear a patient has kidney stones, I automatically assume they have a fatty liver because the same diet causes both. Okay, if a patient has diabetes, fatty liver. If a patient is alcoholic, fatty liver. Roy Taylor did a paper where he showed if the patients could lose 30 pounds or more of weight, all of them that had diabetes 4 years or less, type 2 diabetes, all of them, 100%, they reversed their diabetes or type 2. It's totally reversible if you catch it early enough before you've destroyed the pancreatic beta cells. Pancreatic beta cells of the islets, those are the cells that make the insulin. So you want to reverse it before those have become destroyed so that it's not irreversible. And there's another reason why you want to reverse it. The longer you have this ongoing destruction of beta cells in the pancreas, you're simultaneously having pancreas inflammation. Inflammation, initially you call it hot inflammation, if you will. There's a lot of white blood cells that are releasing toxic products, so it's going to be swollen and edematous. But then it heals with fibrosis, scarring. The fibrotic scarring, laying down a collagen, is going to cause some tissue hypoxia, deprivation of oxygen in some of the cells. Well, anything that deprives a cell of oxygen has the potential to lead to a Warburg effect and transform it into a cancer cell. So what I'm saying is it's just like the liver. When you get a hepatitis, you subsequent to that get liver fibrosis, cirrhosis. Subsequent to that, you have increased risk of liver cancer, hepatocellular carcinoma. And so what I'm saying is you have the same thing going on in the pancreas. You don't want all this stuff. It's bad, and it's easily preventable. Reduce your intake of dietary fat. Okay, the next paper I want to show you about is a paper by Michael Brownlee. Michael Brownlee is his MD, and this is a genius paper. This paper is so beautiful, I started crying when I read this paper. It's just a level of genius like what Michelangelo is to art painting the Sistine Chapel. That's how beautiful this paper was. It was so elegant. It was so brilliant. He won the Banting Award as the best diabetes researcher in the world in 2004. If you go to PubMed, you won't be able to find an abstract, but if you go to the American Diabetic Association, you can find the entire paper for free. If you're willing to sign in and give them your email, you can actually watch Michael Brownlee give his lecture for free. Okay, so that's a pretty amazing thing. And here's the paper, The Pathobiology of Diabetic Complications, a Unifying Mechanism. He figured out how is it that diabetes leads to all these complications. Microvasculopathy causing foot ischemia leading to foot amputations. Diabetic retinopathy leading to blindness. Diabetic nephropathy leading to kidney failure. Okay, and that microvasculopathy also leads to strokes. And the most common reason type 2 diabetics die is for heart disease because it also causes atherosclerosis. The microvasculopathy, it can be in the large vessels, the epicardial coronary arteries, but it can also be in the microvasculature, the penetrating coronary arteries within the heart muscle itself, and that can lead to congestive heart failure, that can lead to atrial fibrillation. Okay, so anyways, it's a magnificent paper. Like I said, it's the best paper ever written in the history of the world about diabetes. It was a Michael Brownlee paper. Okay, now here's what's going on. You get fat, especially saturated fat, and it overwhelms the electron transport chain of the intermitochondrial membrane with electrons, and it just can't handle this. So it can't handle the rapid rate at which protons are pumped into intramembranous space, so it starts to going backwards. There's an assembly line that starts going backwards, and once it starts going backwards, all kinds of bad things happen. Electrons are dropped off the electron carriers, like coenzyme Q. They'll form superoxide anions, and you can normally some of these form and they're quenched by superoxide dismutase, but when you overwhelm the mitochondrial matrix with these dropped electrons, they'll start producing reactive oxygen species, oxidative stress, and destroying intermitochondrial membranes. Okay, and then this causes something that's called overnutrition, and it sends a signal to the plasma membrane to not allow any more glucose to enter the cell. But it's the fat that got there first that's damaging the mitochondria. Here's the guy, Michael Brownlee. This guy is a total genius. His paper is magnificent, magnificent. Like I said, you'll never forget this paper the whole rest of your life. It's so beautiful. It's so elegant. Okay, he summarized all the work he had done. And why did he write such a beautiful paper? Because he has diabetes himself. He's trying to save his own life. And he's a genius, and he figured out how to do it. So it's magnificent, okay? I would say every medical student should read this, and there's not a single one has ever read this. One time when I was first trying to understand diabetes, I figured, well, I'll talk to the diabetes doctors, the endocrine attendings. And I asked the internal medicine doctors, who are the best diabetes doctors in the city where I live? And they gave me 3 names, and I went and spoke to each of those 3 doctors. And let me tell you something, not a single one had read this paper. They don't even know the history of diabetes. They don't know anything about nutrition. I thought it was pathetic. And how could it be that the doctors who are supposed to be the biggest experts on diabetes are ignoramuses? And here's the reason why. What they know is the drugs. They're paid to prescribe the drugs. They're paid to know the drugs. They're paid to teach the drugs. They're not paid to understand diabetes. They're not paid to cure a patient. You cure a patient, you lose a customer. They don't even care about that. As a matter of fact, one of them started asking me silly things. Oh, so you want to live to be 100? I'm like, no, I want to understand this disease so I know how to prevent it and cure it. Okay, that's a completely normal, reasonable thing. That's why I rewrote the textbooks of diabetes, because they're ignorant. They don't include Brownlee. They don't include Shellman. They don't include all the landmark papers. Sweeney, Hemsworth, Rabinowitz, okay? None of that stuff is in there, okay? None of the work of Kempner, nothing about the work of Pritikin, nothing about the work of McDougall. It's ridiculous, okay? All right, so anyways, I'm not going to go into all the details of it, but he goes through every last step, how the polyol pathway is activated, how methylglyoxal is produced to make advanced glycation end products. He goes through every little detail of it. Like I said, it's magnificent. Okay, so again, this is the excess dietary fat inhibiting the inner mitochondrial membrane electron transport. And I was also making the point that hydroxynonenal, it's a toxic aldehyde byproduct of lipid peroxidation from eating omega-6 cooking oils. That will also inhibit the inner mitochondrial membrane. That has a predilection for inhibiting ATP synthase. Okay, and this is what diabetes is all about. So how do you win the game? Don't eat excessive salt. Don't eat excessive fat is the most important thing, especially saturated fat, which is basically saying animal fat. And don't ever eat omega-6 cooking oils. There it is. If you do that, you won't get type 2 diabetes. Okay, and this is just showing, the way the fat progresses from the skeletal muscle to the liver to the pancreas, and then destruction of the end organ characteristic sites in diabetes. This is just showing the concept of when you have excessive fat, it leads to this, what is called overnutrition. And so you initially have overnutrition of fat and the skeletal muscle, postprandial, but then you subsequently get overnutrition of glucose in the cells that can't regulate their rate of glucose uptake, whereby it's constitutive, meaning that it happens in proportion to the concentration of glucose in the blood. So this is the mechanism, okay? And this is sort of, in conjunction with the ectopic fat theory of Gerald Shellman. And I sort of made my own staging system based on the order and the sequence events for all this stuff. And the good news is it's all reversible if you catch it before you got irreversible damage to the pancreas. I've got many more lectures that go into much, much, much more detail about all this diabetes pathophysiology. I have a whole playlist of the detailed mechanisms of diabetes. And of course, with diabetes, you get thickening of the capillary basement membrane, and then you're going to start having less oxygen delivered to the tissues. Then you're going to have increased risk of dementia because your brain cells don't get enough oxygen. Then you're going to have increased risk of other organs turning into cancer because the lack of oxygen delivered to the tissue causes hypoxia, and hypoxia damages mitochondria, and damaged mitochondria leads to the Warburg effect, and the Warburg effect transforms the cell into cancer, like an anaerobic bacteria. So it's all connected to the same thing. And again, how did all this bad stuff start? By eating excessive dietary fat, especially animal fat. And that's why I recommend you eat a low-fat diet. That's why I recommend you eat a 100% vegan diet. Okay, and so that's it for today. I hope that was helpful.